In 1853, the largest cotton mill owner of the era in Manchester built his facility with brick walls 4 feet thick, with a foresight that no one could properly understand at the time. Engineers advised him that 18 inches would be sufficient for a 5-story textile building, yet he still refused to abandon the decision to make the walls thicker. Critics regarded this as a major waste. During the Manchester Blitz in 1940, when German bombs leveled entire city blocks, that mill, which everyone had considered unnecessary, remained standing despite direct hits. Its walls absorbed the blast forces that destroyed modern structures built 70 years later. The critics died in buildings they believed were sufficient. The mill, however, still stands. Under this video, you will see a subscribe button, a small action but one with great meaning. By pressing it, you are not only supporting the creation of more content like this, but also joining a community that values permanence over convenience and substance over speed. Victorian mill owners understood this principle. Build once, build correctly, build to last. A simple subscription shows me that these words have reached you, that the story of engineers who refuse to cut corners has touched someone on the other side of the screen. Like the video and subscribe to the channel, because quality, whether in construction or in content, deserves recognition. Victorian textile mills were not ordinary structures. Between 1780 and 1900, merchants built thousands of cotton, wool, and silk mills across Britain, Lancashire, Yorkshire, and the Midlands. These were the engines of the Industrial Revolution. Massive buildings housing hundreds of looms, employing thousands of workers, operating 24 hours a day. And most mill owners built to minimum standards. Thin walls, wooden floors, cheap construction. But some of these buildings burned, others collapsed, or required constant repair. A minority, however, acted differently. Mill owners in Manchester, Bradford, Oldham, and Rochdale constructed facilities with walls thick enough to stop cannonballs, foundations deep enough to reach bedrock, and fire-resistant structures decades before regulations required them. These were not safety rules or government orders. They were private decisions made by industrialists who believed that permanence was profitable. Wall thickness was the most visible excess. In the 1850s, standard factory construction used brick walls between 18 and 24 inches thick for 5- or 6-story buildings. Structural calculations confirmed this was sufficient for cotton mill loads, machinery, raw materials, finished goods, and workers. The buildings stood, they functioned, but they burned. Textile mills carried catastrophic fire risk. Cotton dust filled the air, highly flammable and explosive in confined spaces. Gas lamps provided light, open flames among combustible materials. Wooden floors were soaked with machine oil. A single spark could engulf an entire factory within minutes. Manchester experienced dozens of mill fires every decade. Hundreds of workers died, owners rebuilt and repeated the same cycle. The solution was obvious, but expensive. Fireproof construction, load-bearing brick walls, cast-iron columns, brick-arched floors, slate roofs, and no exposed timber. This increased construction costs by 30 to 50%. Most mill owners refused, but a small number accepted the expense and added even more. Saltaire Mill, built near Bradford by Titus Salt between 1851 and 1853, used brick walls 3 to 4 feet thick. The main spinning shed measured 550 feet long, 200 feet wide, and 6 stories high, one of the largest industrial buildings in the world at completion. Standard engineering practice suggested that 2-foot walls would be sufficient. Salt specified 4 feet at the base, tapering to 3 feet on the upper floors. The bricks were Carrington Reds, engineering-grade bricks, fired at high temperatures for maximum density, tested for compressive strength exceeding 10,000 pounds per square inch. The mortar was hydraulic lime mixed with crushed brick aggregate, capable of withstanding fire temperatures up to 1,800 degrees Fahrenheit. Foundations extended 15 feet into Yorkshire clay and were filled with mass concrete, far deeper than soil conditions required. The floors consisted of brick arches, spanning between cast-iron beams. There was no timber. Each arch was built on temporary wooden centering, brick by brick, forming a fireproof ceiling for the floor below, and a fireproof floor for the level above. If a fire started anywhere in the building, it could not spread vertically or horizontally. Compartmentalization was total. This approach was not unique to Saltaire. Manningham Mills in Bradford, built between 1871 and 1873, featured brick walls 42 inches thick, supporting a chimney 49 feet high. The chimney, deliberately copied from an Italian bell tower, was not built for aesthetics, but for structural permanence. Its owner, Samuel Conliffe Lister, rejected conventional industrial chimney designs. He wanted a structure that would outlast his business. Dean Clough Mills in Halifax were constructed in stages between 1840 and 1870, and eventually covered 21 acres with interconnected buildings, all with walls 3 to 4 feet thick. The complex housed the largest carpet factory in the world, employing 5,000 workers at peak operation. Fire would have been catastrophic. The walls were insurance. The engineering logic was simple. The benefits of thick walls were as follows. Fire resistance. 4 feet of solid brick does not burn. Internal temperatures in mill fires regularly exceeded 2,000 degrees Fahrenheit, hot enough to melt iron machinery. 4-foot walls contained the heat and prevented spread. Blast resistance. Although not designed for bombs, thick walls naturally resisted explosive forces. During the First World War, several mills near munitions plants survived accidental explosions that destroyed neighboring structures. Longevity. Thick walls distributed loads more evenly, reducing stress on mortar joints and brickwork. This meant slower deterioration and longer service life. Acoustic insulation. Textile machinery was deafeningly loud. 4-foot walls reduced sound transmission to surrounding buildings and streets. Thermal mass. Thick brick walls moderated internal temperatures. In summer, they absorbed heat by day and released it at night. In winter, they retained heat from steam engines and machinery. This improved working conditions and reduced heating costs. The cost was significant. In 1860, a standard 5-story cotton mill cost about £15,000 to build. The same building with 4-foot walls, fireproof floors, and deep foundations rose to £22,000, nearly 50% more, and most owners rejected it, but those who accepted it created permanent structures. During the Second World War, an unplanned test arrived for Victorian mill construction. In the Manchester Blitz of December 1940, German bombers targeted industrial districts. Modern factories with thin walls and steel frames suffered severe damage. Roofs collapsed. Walls failed. Buildings pancaked. Victorian mills, with 4-foot brick walls, remained standing despite direct hits. The blast forces that destroyed 20th-century structures were absorbed by 19th-century masonry. Damage occurred, roofs were destroyed, windows blown out, machinery wrecked, but the walls remained. Fires stayed within compartments instead of consuming entire buildings. Manchester's Ancoats district, built almost entirely of heavy-walled Victorian mills, endured heavy bombing yet retained most structural shells. Post-war surveys showed that mills built before 1880 with walls thicker than 3 feet had survival rates above 80%. Those built after 1900 with thinner walls fell below 30%. This was not deliberate bomb-proofing. Owners who demanded 4-foot walls in 1850 did not anticipate aerial bombardment. 90 years later, they built thick walls to prevent fire and ensure longevity. Blast resistance was an accidental benefit of over-engineering. The post-war period brought decline. British textile production collapsed under foreign competition. Hundreds of mills closed during the 1950s and 1960s. Buildings stood empty. massive brick shells in decaying industrial districts. Demolition seemed inevitable, yet the walls that survived bombing also survived abandonment. In the 1980s, developers discovered that Victorian mills, despite decades of neglect, remained structurally sound. The 4-foot walls required minimal repair. Brick-arched floors were intact. Foundations showed no settlement. Converting these buildings into offices, flats, or shops was cheaper than demolishing and rebuilding. Structures made for cotton looms became homes for hundreds of families. Saltaire today contains shops, restaurants, and art galleries. The 4-foot walls, tight as salt, was said to have wasted money on in 1853, now support modern loads they were never designed for. Manningham Mills, converted into flats in the 1990s, houses more than 300 residents. The 42-inch walls provide sound insulation superior to modern construction. Dean Clough Mills operate as a mixed-use complex of businesses, studios, and homes within buildings built in 1850. The engineering irony is deeper than many can understand. Victorian mill owners built thick walls to prevent fire, a constant threat in textile factories, and those same walls also resisted bombs, a threat unimaginable in 1850, while later adapting usefully, allowing buildings designed for industrial machinery to become residential and commercial spaces. 150 years later, this was not deliberate multi-use design. Over-engineering created unexpected resilience over many decades. Modern factory construction follows different principles. Warehouses and industrial buildings use thin walls, steel frames, and planned obsolescence. A typical modern warehouse is designed for a 30-year lifespan. Walls are 6-inch insulated metal panels. If a building lasts one generation, it has exceeded expectations. Replacement is assumed.
This approach lowers initial cost and allows rapid adaptation to changing needs, but it also means constant demolition and reconstruction. Victorian mills were built once and adapted repeatedly. Modern warehouses are built repeatedly and adapted never. Materials are not the limitation. Modern concrete, steel, and insulation outperform Victorian brick in almost every measurable category. A modern building could easily be constructed to last 200 years. The limitation is intent. Victorian owners built for permanence because they had capital and wanted structures to serve generations. Modern developers build for immediate return and accept replacement as normal. The lesson extends beyond mills. The same logic that produced 4-foot factory walls produced 3-foot sewer tunnels, 6-foot viaduct piers, and 30-foot tunnel foundations. Victorian engineers consistently overbuilt because they knew the future was unpredictable and rebuilding was expensive. Overinvesting at the beginning was better than rebuilding repeatedly. Titus Salt died in 1876. Samuel Cunliffe Lister died in 1906. Neither lived to see their mills survive German bombing or become 21st-century housing. Yet they built knowing the structures would outlive their original purpose. 4-foot walls were not waste. They were recognition that permanence, though expensive at first, becomes economical over time. Victorian mills that survive today, converted into flats, offices, galleries, or still used as light industrial space, share one trait: walls so thick that demolition costs more than renovation. Buildings condemned as expensive in 1850 became profitable property by 2000 because structural excess created longevity. Walk today through Manchester's Ancoats, Bradford's Little Germany, or Halifax's Dean Clough. The mills dominate the landscape, massive brick structures, windows stacked across 6 stories, walls measured in feet rather than inches. Around them stand modern buildings, glass and steel, thin and temporary. Victorian mills remain in every era because owners 170 years ago refused to optimize for their present and instead chose to overbuild for an unknown future. Critics called it waste. History calls it foresight.
Modern engineering calls it a lesson we have forgotten.